In this pencast, we're going to be learning about graphing functions. So this problem says, draw the graph of y equals x cubed minus 3x squared minus x plus 3. So the first thing we want to do is talk about end behavior. Alright, so I've made this chart up here to help us with end behavior. So let's see here. So the first thing we need to look at is if p of x has a leading coefficient of greater than 0 or less than 0. So our leading coefficient, that's the coefficient of the first term, or the one with the highest degree. So our leading coefficient is 1, since the coefficient of x cubed is 1. Alright, so that means that we know we're going to be in this first column right here. So now, we need to look at the degree of the function, whether it's odd or even. So our degree is 3. The degree is the highest exponent of the function. So our highest exponent is cubed, or 3. So our degree is 3. Alright, so from that, we can see that we have an odd degree, which means that we're going to be in the odd degree column right here, which means that this is what our function is going to look like. It's going to look something like this. Alright, so now we know that as x gets closer to infinity, p of x also approaches infinity. And as x approaches negative infinity, p of x approaches negative infinity. Alright, so now to actually graph the function we're given, we just need to get a set of points. So let's make a table. Let's try -3, -2, -1, 0, 1, 2, and 3. Alright, so to do this we're just going to plug the points into the equation we're giving. So -3 cubed minus 3 times -3 squared minus 3 times this should be minus -3 plus 3. Alright, so this is equal to -27 minus 27 plus 3 plus 3, which is equal to -48. Alright, so we'll put that in our table. Alright, so the next one we have to do is -2. So y equals -2 cubed minus 3 -2 squared minus -2 plus 3. Alright, so that's going to simplify to -8 minus 12 plus 2 plus 3. And that's going to be equal to -15. So we're going to put that in our table. Alright, so I bet you can figure the rest of these out on your own, but I'm just going to fill in the table here. So -1, 0, 0, 3, 1, 0, 2, -3, and 3, 0. Alright, so now let's go up and plot these points on our axes. Alright, so our axes only go to about 6, so we're not going to be able to plot the first 2 points. So let's start with -1, 0. So we're going to put -1, 0 right here. Our next point is 0, 3, so we go over to the y-axis and go up 3. That should be right here. Our next point after that is 1, 0, so that's right on the x-axis again. Then we have 2, -3, so over to 2 and then down to -3. And then we have 3, 0 again. Alright, so let's connect these points. Alright, so this is where we get to use the end behavior stuff we figured out at the beginning. So as x approaches infinity, which means as we travel right along the x-axis, the graph has to approach infinity. So we know that from the point 3, 0 that we just plotted, our graph has to go up, like that. Alright, so now we're going to look at the other end behavior. It's going to say as x approaches negative infinity, p of x approaches negative infinity. So if we travel left along the x-axis, that means we need to go down. So from this point -1, 0, we know we need to go down in that way. And that is how you graph that function.